So I want to start this talk off with a question. And that question is, especially now with us all being quarantined in our homes, which is, how many of you like to get away from it all? And that's no thoughts of work. You just pack up your things, you fly to some faraway destination, you put your toes in the sand, and you have a drink in hand. And since I can't see everyone because you guys are, uh, we're all on Zoom, I will raise everyone's hands for them. Um, and so that experience is the typical experience when we're about to go on vacation, right? So your work week, that week before you're about to go on vacation, you're pretty much on autopilot. You've been working on this feature, writing the code for it, and you push it last thing on a Friday, right? You're done with your work, you close your laptop. You're not planning on opening it again until you get back from vacation. You drive home and you throw your bags in the car and you drive to the airport. You get to the airport, sitting there waiting for the plane. Everyone's excited. You're super excited to just be away, and your flight is canceled. And in that exact moment, your relationship with that airline has completely degraded, right? Um, you're not thinking about software bugs. You're not thinking about software issues. All you're worried about is the fact that suddenly you're not going to be able to start your vacation like you expected. And that relationship, when something like that occurs, is paramount. Customer relationships are the focal point. And we all have an airline that I think we refuse to fly, right? It would be a Delta or American. When we have these bad experiences, it can taint our relationship with a business forever. What I want you guys, I think we've all had a bad airline experience, and I want you guys to keep those bad airline experiences in mind. And what I want to do is show you a couple times when maybe a software developer was so excited to go on vacation that they pushed a feature on a Friday afternoon and closed their laptop and didn't think about it. So in 2010, Virgin Blue had to cancel 116 flights for a software outage that lasted them 11 days. In 2017, over 1,000 British Airways flights were canceled due to, again, a massive global software failure. In 2019, over 150 flights out of Heathrow were canceled as, again, a result of a bug in their flight data processing system. Unfortunately, not to pick on British Airlines again, but they're the easiest ones to get this on, is in 2019, both their check-in and departure systems are affected by software issues, and that caused hundreds of cancellations and delays. So one of the things to really think about there is that the people working on those features, those that crash, the check-in systems or the flight data systems, they probably weren't thinking in that moment about passengers sleeping in an airport, right? And what I think is that we really have an obligation to the consumers of the product that we build. And that's across any type of engineering, QA, software, reliability engineering, wherever you are along that, we all have a responsibility to our consumers. And I believe truly that we, again, across the spectrum of reliability engineering, IT, quality assurance, and software, have the power to bridge the gap between the business, which is all about these consumer relationships, and engineering. And what allows us to do that is observability. We can use observability as a tool that allows us to build a bridge and provide actionable insights that help us build and maintain better customer relationships. And this talk is all about showing you how. So to begin, we really have to define two concepts. One is observability and what that means, and the other one is business value. And so observability comes from a subset of mathematics called control theory. And the gist of it is that it is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. It's a little bit hard to understand, but I think that Charity Majors from Honeycomb, which is an observability company, puts it best when can I ask new questions about my system from the outside and understands what's happening on the inside, all without shipping any new code? And so at its core, what observability is truly about is hypothesis-based decision making, right? And when we break down a hypothesis, that is, if something, then something else will happen because reasons. And if we want to get the actual terminology there, that's the if is the independent variable. So that's what we're going to change. And the then is the dependent variable, what we're going to measure. And the rationale, or the because there is the rationale, which is the research that indicates that our hypothesis is correct. And so what observability does for us is gives us that rationale. So observability is providing the data in order to answer those questions. And if you can't answer your hypothesis, then your system is inadequately observable. And at that point, you have to put instrumentation into place that's going to provide you with the data to allow you to answer your educated guesses. And so this is a really old slide from 2006. Marissa Mayer presented at the Web 2.0 conference, but it's a statistic that I've really latched onto for a really long time. But it was from a study that Amazon did, and Amazon found that when you increased latency by 100 milliseconds, that they would see a 1% drop in sales. If we break these down into their core components, you think about, as an engineer, I look at 100 milliseconds. That's a thing that I can probably solve or fix or remediate. And when I look at 1% of sales, I think of that as a business problem. But observability through this hypothesis-driven methodology allows us to actually use it to answer both sides of that. And if we apply the hypothesis model to that slide, you can see here, if I increase my latency by 100 milliseconds, then I will lose 1% of sales because observability, which is all the data and all the instrumentation that Amazon had to put in place in order to get these findings, right? And so once they know this, they can kind of extrapolate that. Okay, what would it look like at 500 milliseconds of latency, 1,000 milliseconds of latency? So this is actually from Business Leadership. There's this phenomenal book by Simon Sinek, Start With Why, and this is what he calls the golden circle. And the idea is that you start in the center and work your way out. Most people start from the outside and work their way in. But when you start from the inside, you're starting with why, right? You want to answer why things occur. And that's truly another way to look at observability, is really providing you with the why. And so the typical thinking with observability is that there are three pillars: metrics, logs, and traces. I actually disagree with this a little bit, in that observability is all about, again, providing data to allow you to make educated guesses. And that means using whatever methodology, data type, tool, code, whatever it is that provides the data to answer the questions. And typically they're going to fall into these three pillars, but I mean, traces weren't around 10 years ago, so I would not be surprised if another vertical appears, especially as this continues to mature. So I know what you're saying, though. A lot of businesses, they have very mature monitoring. And of course, this new buzzword is just like DevOps. A new buzzword comes along, observability. What does it mean to me? I have a bunch of engineers. They built a bunch of dashboards. We have a bunch of TVs all around the office, right? And when problems happen, they all gather around those screens. And they point at them just like this, and they all, then they point to other ones. And, they're able to quickly identify what happened with our systems. The problem with those dashboards is, unfortunately, that while it is phenomenal data, it's kind of too late. And another thing is, do you really want to pay a bunch of engineers to stare at squiggly lines all day, looking for correlations in the data. There's a problem with human beings, and that is that we love to find patterns in things, right? And we will find patterns where no pattern exists. And so I can give you a really good example of this. And I can tell you from working my way through monitoring just like this, there were times when I would just be staring directly at the data and think that I had had some sort of crazy eureka moment and follow down some thread, and you wind up, it means nothing, right? Maybe it was just a smudge on the monitor. But human beings love patterns. So here's a great example. This is a photo of Mars from 1976, I believe. And you might notice that there is a face, and it is staring directly back at you. And for 30 years, we saw a face on Mars, and it's terrifying. There's absolutely a face. Well, in the year 2000, right after the year 2000, we actually took another photo, and yeah, that face is definitely not a face. So human beings, again, we're very pattern driven. And when you have dashboards, not only is it old data of events that have already occurred, but we're really bad at finding patterns, again, in patterns that aren't even there. So the other part is business value. And I think it's put best with thinking about a business as a network of relationships. And that's both internal and external relationships. So when we talk about internal relationships, what we mean there is the employees, the processes by which that you provide your service or product to the customers, and the technology that you use. From the external side, this means customer value, your relationship directly with the customer, your relationships with suppliers, your collaboration with other companies in the market, and then finally, your impact on the market. But for the sake of this talk, I want to focus mostly on customer value. And we can break customer value down into 4 parts. A typical customer will make a decision based on these 4 metrics, which are cost. Am I getting the value of this product or service for what I paid for it? The quality, does it do what it says it's going to do, right? Regularly and reliably. The service, which is when it breaks, is it remediated? A really good example of that is Dyson. You pay a ton of money for a Dyson vacuum cleaner, but if anything breaks on it, they immediately replace it. And then finally, the past experience. And this one encapsulates all of them, but this is how you gain customer loyalty, which is they purchase from you, they get great quality, they get low cost, and they get great service, and then they want to do it again, right? Because they've had such a great experience with you. Or they leverage especially in the world that we live in now, they leverage the past experience of other people. So they go in and look at reviews. So there's this fantastic article written by the ThoughtWorks folks, Ian Cartwright and Martin Fowler, called The Elephant in the Architecture. And it's all about how engineers really should transition and understand more about the business. But there's a quote from them is, business knowledge should be part of a technical career path. And what that really means is not go out and get an MBA, but understand the relationship between the customer, the business's customer, and the business, and how the things that you do in your daily work can affect that relationship. Because at the end of the day, if you don't have customers, you don't have a business. So I want to go through a quick story with you guys and kind of look at what failure looks like through the lens of observability. And so I want to put you in the shoes of an on-call engineer at this company, Acme Logistics. And Acme Logistics is a logistics company, and they ship nationwide. And we're going to split it into 2 lenses for this company. One where they are just at the very beginning, or maybe haven't even started their observability journey, and the other one where they're much more mature on their observability journey. So the first one, and if you guys have ever been on call, I just unfortunately might bring up some bad memories, but this one starts at 3 o'clock in the morning, and you receive a page, and you roll over, and you're very tired. You roll over, you check your phone, and this is the message that you get: CPU usage is high on production infrastructure O1. So you start to roll out of bed and to grab your laptop, and as you do that, other alerts start to fire. CPU usage is high on production infrastructure O2, O3, O4, O5. Yeah, that's every production node. So open your laptop open and you start doing some cursory poking around, and it looks like it's the Docker process, but it's on every machine. And so you do what you always do, and you begin a conference bridge and you start calling other engineers to get involved. The conversation goes a little like this. Person answers the phone and they're very tired. Hey, what's up? And you break it down for them. Yeah, CPU usage is high on all of our production machines. I'm not sure why. Looks like it could be Docker, but it's impacting everything. Have any thoughts? And of course, not knowing what's been done before, you get suggestions that are coming at you rapid fire. You've tried some you haven't, and more people are joining the call as people are trying to solve this. And it's absolutely disorganized chaos. And so as the investigation drags on, other people are again joining in. Everyone's being caught up to speed. There's crosstalk. It's incredibly hard to concentrate. And that's when you hear the ding of someone joining the call, and everyone goes really quiet, and you hear this familiar voice. It's your VP of infrastructure. And he says to you, yeah, I just got a call from Larry over in trucking support, and he said they're getting hit with a ton of calls from drivers who are unable to get their documents to load to make deliveries. But what's going on? And you reiterate the same thing you've reiterated to everyone before. CPU usage is high on all the production boxes, and Docker's going crazy, and well, we're not sure why. And he starts rapid fire questioning. How many documents are we unable to send? What's the impact here? Is it every delivery? Do we have anything to help Larry communicate with the drivers and let them know when they can make some deliveries? So that's when you know it's going to be an absolutely long night or early morning. So let's look at this through the same company, the same lens of a logistics company, but with much more observability, so much farther along on that journey. And so it's 3 p.m. the previous day from when that 3 a.m. alert fired. And you receive an alert that reads a little like this. Failed delivery rate is elevated in region Northwest. And so you begin to investigate. One of the nice things about this error message is that this is not system related. This is very much customer related, right? So the customers here are the people that are receiving these deliveries. So I know just from this error message immediately where the scope is. It's in the region Northwest, and I know what's going on, that we're not able to make deliveries. So already in my mind, instead of thinking high CPU usage, I'm already thinking, yeah, okay, so this is impacting deliveries for the Northwest. This is a big deal. And so breaking that down, again, thinking about that, okay, so I know, okay, this is affecting, all these states. None of these trucks are able to make these deliveries. And that's when you start pouring through the data. And as you're investigating, you see that one of the terminal hubs, which a terminal hub is where the trucks all get their deliveries for this area, and then they drive to their individual delivery locations. One of them is erroring at 100%. And what this means is that all those delivery drivers from this terminal hub are not able to make their deliveries. So you look into these transactions for this hub ID, and we'll break this down really quickly by the system. But what is happening as you investigate, you find that this terminal ID, or this terminal hub, has been uploading documents that are malformed. And so when they go up to the upload API, it's having trouble processing them, and then it's causing latency to the retrieval API, and the documents are not being delivered correctly to the drivers. And so you might notice that I've kind of glossed over the technical details here. And that's because what's really important here is more the narrative. And so the important thing to take away here is this, which is, again, going back, you understand where the fault is happening, what's the impact. And so you pick up the phone and you proactively call Larry in trucking support. And you explain the situation. So the conversation goes a little like this. Hey, Larry, I have an issue here that's going to impact our West Coast drivers making deliveries. It looks like drivers aren't able to retrieve documents that were uploaded by a specific hub. It looks like that hub is sending us malformed documents. And what that's doing is it's causing increased document retrieval times for other drivers. And it looks like there's a little bit of system impact. I can see that the hub is pretty low traffic right now, but they do the majority of their transactions overnight from around midnight to 4 a.m. So that impact is going to grow. And then Larry is able to proactively reach out to that hub, and they find that they have a glitch in their third-party transportation management software, and it's causing those malformed documents to be uploaded. So TMS fixes it immediately, and Larry is able to send out a blast to all the drivers to let them know the impact, that they're going to have to rely on another method in order to complete their deliveries. And he thanks you very profusely, because this could have affected the entire Northwestern delivery chain. And that night, you sleep very well. So what makes these two, the same company, but what makes them different? Well, the second company is a modern data-driven organization. And they use hypothesis-driven decision-making. So they're doing observability. And their hypotheses are all end-user outcomes. So you might, again, have noticed that alert is very much an end-user outcome-focused alert, which is deliveries in the Northwestern region are impacted. And this transcends across all the different disciplines. So from a software engineering perspective, the code is instrumented with granular, high cardinality metadata, which allows them to slice and dice the data to get things like, the region specific or truck specific. When it comes to QA engineering, the QA are able to rigorously test high value features and flows. And the way that they're able to do that is because they're educated by the real world usage. Because everything is instrumented to show how traffic flows through the system, they are able to understand that when a big feature is rolling out, if it is affecting a system that processes 30 million transactions a day, that needs much more rigor around testing than something that processes 10 transactions a day. And then finally, again, as we've gone over, alerts are actionable and directly apply to end user outcomes. So when things happen, the lens by which everyone looks at an issue is how it impacts the customer, right? How does it impact them using the system? So that all sounds great, but how do you do it? And I think it all starts with don't boil the ocean. Truly, like, you can start with this. This methodology of observability is really easy to get started with. And what that is come up with your hypothesis, right? Okay, so I think that this thing will do this, and then instrument until you can answer the question. A really good example for this is actually technical debt. So we all have a gut feeling about technical debt. And we all say, like, technical debt to us always is like, oh, if I could just fix this thing, right? And it's really hard to justify to the business how to take care of technical debt, because it's usually just a gut reaction, or, oh, we're just throwing code, we're just leaving behind us a trail of bad code. And what observability allows you to do is actually change that narrative. And if you think that a piece of technical debt is customer impacting or could have a really big impact, then you instrument it. And then what that allows you to do is change the conversation from going to, a product manager or the business and saying, we really need to fix all this technical debt, everything's on fire, to saying, if we fix this one piece of technical debt, this will improve performance of this API by 100% that processes $30 million a day in transactions, right? Which has an immediate end user outcome. The other thing for engineers is to speak to the business. And this doesn't have to be business leadership. This can be salespeople and all the way down, because salespeople work directly with those customers, and salespeople want to foster and nurture those relationships for retention, for initial sales. And they can really educate you on where the customer is feeling pain, or if the feature that you're developing, which you might not really understand, oh, why are we doing this? They can give you a better understanding of, why. And that really goes into listening, right? Not saying, oh, they're the business, blah, 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 we're engineering, but really, again, listening to them and thinking again about how the work that you're doing directly impacts the customer. So that ties directly into thinking about end user outcomes in your work. Going back to the original airline example, if you're writing airline software that processes check-ins, think about that feeling of what it would feel like to have to sleep in an airport, right? And maybe that also can guide you with the instrumentation, which is really, that's the worst customer experience, right? Is when a flight is canceled, or when the system goes down and people are stuck. And so that's a really good point of, okay, I should instrument for these things so that I have visibility into how these are being used and how it's performing and what happens when it fails. And so again, going back to the hypothesis, this is it. If you can't answer a question, instrument. That is the guiding principle. It's a loop. Have an educated guess, make sure that you have the data to make the educated guess, and then you've made that guess, make another one. And this makes it where it's a much more proactive experience than a reactive experience. So I want to wrap this up with two quotes. And the first one is, if you don't learn to sell, you're always going to be working for someone who does know how to sell. And this doesn't mean vacuum cleaners door to door. This means being able to sell your ideas. And what observability does is actually allow you to sell your ideas, because when you can go to the business and say, this piece of technical debt or this feature will provide this, this customer outcome, that conversation has bridged the gap between them. And observability 100% is, we can all see through a thin salesperson who, paper thin salesperson who doesn't really understand the consequences. They just, fast car, right? But observability allows you to say, okay, we need to prioritize this technical debt or this feature because here is the customer impact. Or if this thing goes down, there will be people sleeping in the airport. And then finally, to come back to this slide one more time, is this idea that business knowledge should be a part of a technical career path. Really understanding how the business operates allows you to really understand what you should instrument and how you should approach observability, because understanding how that customer and business relationship is maintained, and especially understanding how it can fall apart, really allows you to begin to instrument the code to answer the questions of, hey, are we doing the right things for the customers? Are they dropping out of the sales funnel at a certain point? Why are they leaving? Is it performance related? Is it, reliability related? So again, not an MBA, but really just understanding that customer experience and thinking about, through the lens of a customer. We've all are a customer of something, can help you to understand how to go along the observability journey.